Hello everyone, welcome to the channel Unshackling Sudokus and Puzzles. Today's video will be on a positive ring Sudoku created by Sudokuexplorer. Yesterday on the channel we had covered the Phistomefel Ring Theory, which is applicable for any Sudoku regardless of the type of variant, be it Classic Sudoku or any Sudoku variant. You will have the Phistomefel Ring Theory applicable or true for each and every Sudoku. If you haven't watched the video yet, we would highly recommend you to watch the video. And a small clarification that we would like to add from yesterday's video is that it is not necessary that the technique will help you solve faster in each and every Sudoku that you see. Wherever the author has intended that step to be found, there the technique will be really helpful. So this is a small clarification we like to add. And today's video will be on one such Sudoku which uses the Phistomefel Ring Theory. To be frank, I am not really certain if this Sudoku is even solvable without that theory, because I haven't even tried that myself. So in this video today we'll see how to solve this Sudoku using the Phistomefel Ring Theory at a crucial point. I will explain that in the later stage. And before that, if you want to try the Sudoku yourself, please check the online solving link given in the description of the video. And do remember to subscribe to the channel. So let us start the Sudoku, and the rules are irregular Sudoku rules apply. That is, each row, each column and each irregular region. You can see that the regions are not 3 by 3 here, but rather irregular in shapes, and they are all 9 in size. So which means that each irregular region will also contain digits from 1 to 9. The next part is the killer part. So digits in caged areas will add up to the clue given in the top left corner of the cage. So which means that digits cannot repeat inside the cage, and if you sum those digits, then you will get 15. So for example, if you take this cage, the sum of these three digits will be equal to 19. So the theme of this Sudoku is positive ring. As you can see, there is a ring inside the grid, and it's an irregular killer Sudoku. So having said that, we'll start solving the Sudoku now. And before that, I'll just change the tab to number normal and number middle. Okay, sorry for that. Okay, so let us see if the killer cages are helping us. Okay, 59 is going to be only two possibilities, 69 or 78. We have a 15 here too, so it should be 69 or 78. No other 15s inside the grid. Maybe we can look at 6. 6 would be 1 5 or 2 4. 7 has 3 possibilities. 10 has 4. Okay, lots of possibilities for the rest of the digits. But one thing for small thing is that if you have 6 plus 9 here, this becomes 7 plus 8. And if you have a 7 plus 8 here, this becomes 6 plus 9, right? So you can see from the geometry of the grid something very unique to this grid. So if you look at rows 1, 2 and 3, we have a box which contains 1 to 9. We have another box which contains 1 to 9, and we also know that 3 rows will always have 3 sets of 1 to 9. So one of the set 1 to 9 is here, one of the set 1 to 9 here, which means that we'll have one more set of 1 to 9 into these 9 cells, 1, 2, 3, 4, 5, 6 and 7, 8 and 9. Fascinating, right? So this is true for each and every corner of the grid. If you take these two boxes, columns 7, 8 and 9, then this area will contain 1 to 9. Same idea, right? 3 sets of 1 to 9. One of the set of 1 to 9 comes here, the other set comes here, and this box will contain 1 to 9. Similarly, this box will contain 1 to 9, and this box will also contain 1 to 9. So in effect, this is reduced to a classic Sudoku grid. So remember, the Phistomefel ring theory is applicable only to a grid which has 3 by 3 regions. So we have basically reduced this Sudoku to a classic grid, right? Each of these 3 by 3 box in the grid will also contain digits from 1 to 9. So let us see if that is helping us. Okay, so you have a 6 here and you have a 10 here, and whatever these 4 digits are must be in this plus shaped region, right? So these 4 digits cannot get into these 5 cells, which means they must be going into these 4 cells. So the sum of these 4 cells is going to become 16, right? Because 6 and 10 will give you 16, and those same 4 digits will get inside here. So they will be summing up to 16, right? And we also know that for the column, in any row, column or box of a Sudoku grid, the sum of the digits will be 1 to 9, which is equal to 45. So you have 16 from these 4 cells, 12 plus 13 already in the cages, which is equal to 25 plus 16, 41. So which means that this cell is going to be 4. Beautiful, right? Nice start to the Sudoku. So which means that this cage cannot be a 2, 4 now. It's going to be 1 plus 5. Oops. What happened? It's going to be a 1 plus 5. So, and the 10 cage now is either 2, 8 or 3, 7, because 1 and 9 and 4 and 6 are immediately ruled out. So which means that 1, 5, 2, 3, 7, 8 is going to be inside these cells, right? So let us see if that is helping us. So at least we can corner pencil mark 1, 5 into these cells. And now if you look at the 12 cage, it cannot be 4 plus 8, it cannot be 5 plus 7. So which means that the 12 cage has only one option left. It is going to be a 3 and a 9, right? Let me put the 3, 9. Okay, something else is ticked, guys. Sorry, number. Sorry for this. Should have ticked this Sudoku normal and Sudoku center. Okay, so now it should be fine. So let us look at the 13 cage now. It's not going to be 4 plus 9, and it is also not going to be 5 plus 8. So the only option left to us is 6 plus 7. So let us put that inside. And now we know that 3 and 9 and 6 and 7, right, are going to be inside these 4 cells, because they cannot be present in these 5 cells, and this irregular shaped region contains digits from 1 to 9. So these 4 digits must be 3, 6, 7 and 9. So let us pencil mark them. And now we are sure what is the 10 cage going to be. It cannot be 3 plus 7, it's going to be 2 plus 8. So nice start to the Sudoku. And now we can write the possibilities in these cells also. This becomes 1, 2, 5, 8, right? 1, 2, 5 and 8. And with that we can remove the corner pencil marks. Okay, this is beautiful, guys. Not only can we establish that this 3 by 3 region, these 4 boxes also contains 1 to 9, and because of which this middle box will also have 1 to 9, because there are 8 sets of 1 to 9 inside these boxes. So the middle box will also have digits from 1 to 9. One more small thing is the law of leftovers, or the in-out rule that you specifically see in irregular Sudokus. Now we know that this is an irregular Sudoku, and if you look at rows 1 to 4, right, so they will have 4 sets of 1 to 9, right? Now we have a region which is fully inside those 4 sets. So this region will contain one set of 1 to 9. This region contains another set of 1 to 9. This region contains another set of 1 to 9. So whichever cell is remaining, right, these cells, the cells in red, will also have digits from 1 to 9. Beautiful, right? So this region, if you look at this region, exactly 2 cells from the region are going outside, which means that it is losing 2 digits from its area. And now for the balance to be preserved, whichever cells which come inside those top 4 rows must also contain the same digits as this, right? So that it contains digits from 1 to 9. Beautiful, right? So which means that these 2 cells cannot be 1 and 5, they must be 2 and 8. Because whatever comes here must be equal to here. This is the law of leftover, or the in-out rule for irregular Sudoku. The same idea can be used at the bottom, because the grid is symmetric. Yes, you can use at the bottom as well, or you can use simply classic. So for this instance I will explain again how to use the in-out rule. So if you draw an imaginary line after 1, 2, 3, 4, 5, fifth row, you will see that there are exactly 3 regions which are fully inside, and we know that last 4 rows will have 4 sets of 1 to 9. So we have already got our 3 sets of 1 to 9. So one more set of 1 to 9 will be from the highlighted cells, right? And now if you look at this region, this will contain 1 to 9, and it is losing 2 digits outside this area. So which means that whichever 2 digits come inside would have to be the same as this, right? So that we get 4 sets of 1 to 9. So which means that this is not 1 and 5, this is going to be this is not 2 and 8, this is going to be 1 and 5. So we got a good start to the Sudoku. The same thing can also be used at this side. If you draw an imaginary line, what is going on? Okay, sorry. If you draw an imaginary line after column 4, you will see that these two cells are equal to these two cells, which means 6 and 7 can be removed from here, and 3 and 9 can be removed from here. These two cells will be equal to these two cells. This is specifically true for this Sudoku, right? Okay, so at this point we can use the Phistomefel ring theory, guys, because okay, before that I'll just quickly say what is the Phistomefel ring theory for those of you who have not seen yesterday's video. So in any Sudoku, the ring theory states that any Sudoku, doesn't matter which variant, but any 9 by 9 grid with 3 by 3 regions, right? This is the Phistomefel ring theory. The 16 digits in these 2 by 2 regions, there are 4 blue regions that I've highlighted here. The 16 digits in these 4 2 by 2 regions will go into this green region, which also contains 16 digits. If you count carefully, there will be 16 digits in this ring. So in any Sudoku, the 16 digits which go inside here must be the same, exactly the same as the 16 digits inside this ring. Now we may wonder, how come this is true? Is this true for all Sudokus? This is some of the questions that we also got when we first came to see this theory. But it is true. You can, for example, you can take any Sudoku solution that you see, and you will notice that the 16 digits in these 2 by 2 blue region is equal to the 16 digits in this ring, green ring. So a small proof of this theorem, if you want to get convinced that this is true, the small proof of this theorem is that I'll highlight some regions to explain you. This was also explained in yesterday's video, so I'll again quickly show for those of you who haven't seen yesterday's video. So basically I'm going to prove that this is true by considering 8 sets of 1 to 9, right? 8 sets of 1 to 9. So I can define 8 sets of 1 to 9 in 2 ways. The first way is row 1 plus row 2 plus row 8 plus row 9 plus column 1 plus column 2 plus column 8 plus column 9, right? 8 sets of 1 to 9. So if I add these 4 rows and if I add these 4 columns, the extreme rows and the extreme columns, I'll have 8 sets of 1 to 9, right? Now I'm going to define them in terms of the colored regions. So you will notice that when I add 8 sets of 1 to 9, all the red regions get added once and all the blue regions get added twice, right? Because when you add row 1, row 2 and column 1, column 2, you will notice that these 4 cells are being added twice each. So which means that the 8 sets of 1 to 9 can be defined this way. I'll quickly write something here maybe. Oops. Yeah. So the 8 sets of 1 to 9 may be defined by this way: blue plus red plus blue, right? Blue regions means these 16 cells. So blue regions are getting added twice and all the red regions 1, 2, 3, 4 are getting added once, right? And now I'll define the 8 sets of 1 to 9 in a different way, right? 8 sets of 1 to 9 is also equal to sum of boxes 1, 2, 3, 4, 6, 7, 8 and 9, except the middle box. You can say that if you add 8 boxes except the middle box, you will have 8 sets of 1 to 9. And now I am going to define them in terms of the colored regions. So you will see that these the sum of the digits in these boxes is equal to all the blue regions once, 1, 2, 3, 4, all the red regions once, right, and the green region once. Hope it's clear. So both of these expressions are basically the same, right? 8 sets of 1 to 9 is defined in terms of blue region plus blue region again and plus the red regions, and 8 boxes again 8 sets of 1 to 9 is also equal to the blue regions, the red regions once and the green region once. So which means that both of the expressions can be equated, and you will see that the blue regions cancel out each other once, the red regions cancel out each other. So which means that the blue region is equal to the green region in any Sudoku, right? This is true for any Sudoku, guys, which has a 9 by 9 grid and which has 3 by 3 subgrids inside them, 3 by 3 boxes I mean. So all the digits in these 16 cells will be equal to the digits in this green region. So this is the Phistomefel ring theorem. So do check out yesterday's video too, where we had explained this theory alone in detail and also the variations of it. So now we'll use this theory inside the Sudoku. So if you look at this grid, because all these boxes are 3 by 3 as we established earlier, you will see that the 2 by 2 regions are in the yellow cells, but we don't know what is the composition of digits inside them. But what we know for sure is the sum of those digits. You will see that all these killer 2 by 2 regions have killer cages inside them. So let us add them. 10 plus 11 is 21, 21 plus 15 36 plus 9 45 plus 7 52 plus 15 67 plus 10 77 plus 7 is 84. So which means that one thing for certain is all these ring cells, right, shaped cells will have digits which sum to 84. And now if you look closely again, this ring is completely covered by cages except these 4 cells. So we'll add the cages now. 21 plus 16 is 37, 37 plus 19 is 56, 56 plus 11 is 67. So on the left hand side we had 84 and from these cages we have 67. So which means that these 4 cells must add up to 17 to show that so that the Phistomefel's theory becomes true. Right, now we are going to use that. How do we get 17 from these 4 cells? Let us see how to get 17 from here. So if I have a 2 here, and this can be 3 or 9, right? So 2 plus 3, 6, 2 plus 9, 11. Okay, so if I have a 2 here, there is no way I am going to get 17 from these 4 cells. You can quickly see. So let us put a 2 here. I'm sorry, I'll use a corner pencil mark. Let us have a 2 here, which means that this can be 3 or 9. Let us go with the 3 here. And now this can be 1 or 5 and this can be 6 or 7. But now we need to get 12 from these 2 cells. No way it's going to be possible. Oh, this is possible, guys. 5 plus 7 is 12, right? So I'm sorry. So 2 is actually possible here. Let us try maybe from a different cell to see if we can eliminate something. Let us try with the 6. 6 plus 5 is 11 and we need 6 more, not going to happen. 6 plus 1 is 7, we need 10 more. Okay guys, so 6 is not possible in this cell, guys. So when you have a 6 here, this can be 1 or 5, right? Let us go with a 1 and now these 2 cells add up to 7. Now which means these 2 cells must add up to 10 to get 17 and there is no way 10 going to be possible from these cells, so 1 is not going to be here. Let us go with the 5 now. 6 plus 5 is 11 and we need 6 more from these 2 cells, which is again not possible. 2 plus 3 is 5, 2 plus 9 is 11, which is not possible. So which means that you cannot have a 6 going inside here, right? Because we have eliminated all the possibilities using the 6. So this will be a 7, this will be a 7 and this would be a 6. So look how the Phistomefel theory is helping us to put the first digit inside the grid, guys. So to be very frank, I have solved this Sudoku previously and I'm not really certain if this Sudoku can be completed using the theory. Maybe you guys can let us know if you solve this Sudoku, if you manage to solve this Sudoku without this theory in the comments of the video. We'll be extremely happy to see how you manage to solve that. So now we have 7 and these 3 cells must add up to 10 now, and that is going to be possible only if you don't have a 9 here. So 9 is ruled out from here, so this is 3. So 7 plus 3 is 10, which means that these 2 cells must add up to 7 more, which is only going to be possible if you have a 2 here and a 5 here. So this becomes 1, this becomes 9 and this becomes 8. Fantastic, guys. So we have got some important breakthrough inside this Sudoku. Now let us attempt to continue the Sudoku further. Okay, so we can do something using the irregular part. We know that we have a 1-5 pair here, so which means that these cells, these digits are inside this region, so 1-5 cannot go here, so which means that we will have a 1-5 inside these 4 cells, right? And we also know that 3 and 9 is inside this irregular shaped region. So 3, 9 cannot be here, and for row 4 we need to have 3, 9, so which means that 3, 9 goes into these cells. And similarly 2, 8 cannot be inside this region, so 2, 8 would have to be here for the column 6. and 6 7 cannot be inside this these 4 cells because this is part of the same region, and for row 6 6 7 would have to be here, right? And we can eliminate the 1 from 21 cage because 3 cells 21 is not going to have a 1, right? Let us remove the 1. So the 9 cage, I mean the 21 cage is going to be 6 plus 7 plus 8 if we don't have a 9 inside the cage, but 9 can go here, right? 9 is already eliminated from these 2 cells, but 9 can get inside here. So it's not going to be useful. Okay, this box contains 1 to 9, so we have 2 3 9 already here, so which means that 2 cannot go here and 2 3 9 cannot go here. Okay, so 6 is inside in column 6, right? 6 cannot go here, which means that these 6 cells will have a 6 inside them, right? Because this box contains 1 to 9, so 6 would be inside these cells, and 9 is not going to be here, which means that 9 must be inside these 3 cells because 9 is inside this box. And similarly, we can use the fact that 8 cannot be inside these 3 cells, which means that 8 must be in these cells, right? Yeah, 8 cannot be inside these 3 cells, which means that 8 must be here, and 1 cannot be inside these 3 cells, which means that 1 must be here. This is all based on the fact that these corner 3 by 3 boxes also contain digits from 1 to 9, right? Now let us see if we can use that further. Okay, so we have got a 9 here, right? So which means that I can eliminate the 9 from here. So 9 is restricted to these cells. And I've marked 6 to one of these 3 cells, right? Which means I can remove the 6 from these 3 cells. So 6 is inside this 3 cells, 8 is inside these 3 cells, and 7 can be in any of these 4 cells. Okay. Still the Sudoku seems to be harder, guys. So can we resolve this 15 cage? It can be still 6 plus 9 or 7 plus 8, not 8. Oh, beautiful, guys. So we also have a 1 here, right, from these 4 cells. So which means that for this 3 by 3 box, you will have 1 inside these 3 cells. So we deduce that 1 is inside these 3 cells and 9 is inside these 3 cells and 2 and 8 is inside these 4 cells. So which means that we are certain that 1 of 2 and 8 will be inside and both 1 and 9 will be inside. So I can remove these pencil marks and replace them by center pencil marks, which are going to be 1 to 8 and 9. And this cell is going to be 2 or 8, right? Depending on which digit of 2 or 8 goes inside here. So this is going to be 2 or 8. So which means that I'll have 3 5 inside these. Oh, I'm doing some mistake here. Okay, 5 is already here, right? So for this 3 by 3 box, I need to have 3 and 4 inside these cells, right? So these cells will be 3 4. Let me use corner pencil mark. So 3 and 4 is going to go here. Okay, for the 19 cage, I cannot have 1 inside the cage. So this will be 2 8 and 9, right? And if I have a 2 here, then these 2 cells must be 8 and 9 to satisfy the 19 value, but this cell row 6 column 7 cannot take 8 or 9 because we already have 8 and 9 inside here, right? So this is not a 2, so this is 8 and 9. Okay. So we just need to resolve one cage, guys, and the Sudoku can be quickly completed, but that doesn't seem to be likely here. Okay. So we have a 9 coming from row 4. We know that 9 is going to be in these 3 cells. So for this 3 by 3 box, you cannot have the 9 here. So which means that the 9 is going to be inside these 3 cells. And we already deduced that 6 is inside these 3 cells. 8 is inside these 3 cells. Right, because we have corner pencil mark. So we just need to see the corner pencil mark at this stage. So we have 6 inside these 3 cells and 8 is inside these 3 cells. And 7 inside these 4 cells and 9 inside these 4 cells. So which means that basically these 3 cells will be comprised of 6, 7, 8 and 9, right? Let me remove the corner pencil marks. 6, 7, 8 and 9. Because 8 is not going to be inside these 3 cells, so 8 goes here. And 9 is not going to be inside this cell, so which means 9 goes inside this irregular region, so 9 comes here. So 8 and 9 here for sure. And 6 and 7 are going to be here, right? Because this 3 by 3 box will contain has a 6 7 here, so which means there is no 6 7 here, so the 6 7 goes here, so this cell will be 6 or 7. And because we have an 8 here, this cell is not an 8. Superb, guys. So we've got the breakthrough we have been looking for, I guess. So this becomes 2, there is no 8 there, so this is a 2, which means that these 2 cells are not 2. So this becomes 1 8 9 pair, and this becomes 2 3 4 for the 3 by 3 box. And now these cells for row 6 must be 3 4 5, because 1 2 6 7 8 and 9, so this will be 3 4 5. And so we can write these digits now: 2 6 1 8 and 9, so this will be 3 4 5 and 7, but 3 cannot be inside these 3 cells because you have a 3 9 here, and this 3 by 3 box contains 1 to 9, so no 3 here though. So there is only one cell for the 3, so this becomes 3, and which means these cells will be 4 5 and 7, and these cells will be 2 3 9 4 5 7, so these cells will be 1 6 and 8, and this cell cannot be a 6 now, so this is going to be a 7, and there is no 7 here, this will be 6 8 and 9, so this is going to be a 5. Beautiful, guys. So we are getting digits quickly now, and this is not a 1 because 21 kg can't contain a 1, so this is 6 or 8. So 1 5 6 8 3 and 9, so this irregular shaped region, the remaining digits are 2 4 and 7, so you can't have 2 inside this 21 kg, so this is 4 and 7, and these cells must be 1 6 9 for the row. So let us try to resolve one of the cages, guys. I think that is the way to go about it now. So in 11 cage, 3 cell 11 cage, you cannot have the digit 9 inside it, so this is not a 9. So if I have a 4 here, this becomes 8 and 9. If I have a 7 here, this becomes 6 and 8, right? So this will be 6 8 and 9. A 4 gives you 8 and 9, so I have written 8 and 9 here. And a 7 gives you 5 9 or 6 8, but you can have only 6 and 8 here, so this will also be 6 and 8. So these are the possibilities here. Okay, you can remove the 3 from this cage, because if you have 3 here, then 19 becomes 7 plus 9. There is no way to place the 7 here, so this is not a 3, this is 4 or 5. So 8 needs to have 11 from here, which would be 5 and 6, right? If I have the 8. So, and 9 needs to have 10 from this cell, which means it would be 4 plus 6. Okay, so this cell is 6, guys. A really crucial deduction. So from these two cells, you will have either 8 plus 4, which is 12, and you need to have the 7 here, which is not possible. So 8 plus 5, 13, so 6 would be here. And if you have the 9 plus 5 is 14, and you need to have again 5 to satisfy the 19 total, or you can have 9 plus 4, which is 14, and 9 plus 4, which is 13, and you can have the 6 here. So this cell will be 6 regardless of whatever possibilities come here. This has to be 6, which means that this is not a 6, this would be 7 8, the 15 kg, which means that this would be 6 and 7, and which means this would be 6 and 9. This would be 6 and 9. Okay, and now this has to be 1. These two cells are not a 1, there is going to be 6 and 9. And this 6 gives a 9 here and a 6 here. And now these two cells must sum up to 7 for the 16 kg. So 7 is ruled out from here, so 4 plus 3 or 5 plus 2. So 2 is already here, which means that this is a 3 and 12, so this is a 4, which means these two cells will be 5, 7. And now if you look at the 7 kg, it cannot be 3 plus 4 or 1 plus 6, so it is going to be 2 and 5, which means that you can resolve the 2, 8 pair inside the grid, and which means 7 and 8 can be resolved, and this cell is not a 5. Okay, so the 9 kg has only one possibility, not 1 plus 8, not 2 plus 7, not 3 plus 6. So this is going to be 4 plus 5, and you have a 5 here. So this is a 5, this is a 4, this is a 3, this is a 5, 3, 4, 5. So this is a 5, this is a 4, and 2, 5, 3, 6, 8, 4, 7. So remaining digits are 1 and 9. You have a 9 here. So this is 1, this is 9. And these two cells must be 3, 7 for column 8, 1, 2, 4, 6, 9, 5, 8. So 3 and 7, you have a 3 here. So this is 7, this is 3, and these two digits must be 1 and 2 for this box. So these two digits must be 4 and 8. So we are going to get digits now thick and fast, guys. I think the Sudoku is done. So you have a 3 here, so which means this is not a 3, this is 2 and 4. Okay, 5 plus 6 is 11, so this must be 8. So this is not an 8, so this is 1 and 9. The 4 here removes the 4 from here. Okay, so if you look at this 11 kg, if you have a 6 here, you need to get 5 from these cells, which is not 2 plus 3, so 4 plus 1. And if you have an 8 here, these two cells must add up to 3, which means it would be 2 plus 1. So this will be 1 regardless of the possibilities here. So this would have to be a 1. So the remaining cells here must be 2, 4 and 7. Right, 7 is going inside here. So there must be a 5 here for row 3. Okay, so we know that in this box, 1 has to be inside these 4 cells, right? Because of the 1 in column 3 and 1 in row 3. 1 would have to be in these 4 cells, but 1 cannot go here, because if you have a 1 9 here, then you'll in rows 1 and 2 you will have 3 9s. That is one of the 9s should be here, one of the 9s should be here, and one of the 9s should be here. So 1 would have to go here. So this is a 1 and 6, which means this is not a 6. This is not a 6, this would have to be 8. This has to be 6, this has to be 1. And now these two cells must sum up to 15, and that is going to be only possible with 8 and 7. And these two cells must be 2 and 4. Because of this 6, you get a 6 here and a 4 here. So this becomes 2, 3. And these two cells must be 5, 9. Okay, 1, 6, 8, 5 and 9. So there is only one possibility here, which is 3 plus 7. Can't be 2, 8, can't be 1, 9, can't be 4, 6. So this would be 2 and 4. And this would be 5, 9. So stay tuned for the flurry of digits at the end of the grid, guys. So we have made so many pencil marks. If we get one digit, the Sudoku is going to have a thrilling finish to it. So this will be 8 and 9, 1, 5, 9, 2 and 7. So 3, 4, 6 and 8. So out of which 10 has to take 4 and 6, and 11 has to take 3 and 8. And now we need one more digit to finish these digits at the boundary. So you have an 8 here, so which means this is 8, this is 9, this is 9, this is 5, this is 5, this is 1, 1, 6. Okay, so this 6 gives a 6 and a 9, 3, and this 8 resolves this 8, 4 pair, a 4, 2 pair, a 2, 5, a 5, 7. So you have a 4 here, so this would be 4 and 6. And this 8 gives 8, 3, 3, 2, 2, 1, 1, 9 and 9, 5. Because of this 3 you get 3 7, a 7 2 and a 2 4. And with that we have completed this masterful creation from Sudoku Explorer, a brilliant Sudoku which made use of the Phistomefel Ring Theory to the fullest. Hope you guys enjoyed watching me solve this Sudoku. We had great fun covering a video on the Phistomefel Ring Theory for you. So please let us know your thoughts in comments. Stay safe until we catch you again with a video. Take care. Bye bye.